Hello, this video is on section 3.1, which is titled Lines and Angles. And there are two learning targets for this. The first one is to identify relationships between figures in space. And the second one is to identify angles formed by two lines and a transversal. This section has quite a bit of definitions, vocab, and terminology. So we'll get started right into the first few that should be somewhat familiar. The first one is parallel lines. And if a line is parallel to another, that just means it is a line that doesn't intersect with another one. So the symbols that you may see are two straight vertical lines, and let's say we have a diagram of these two lines that are A, B, and CD. When you're writing that AB is parallel to CD, you just write the line segments on opposite sides of these two vertical lines. And then you can also see some symbols on your diagram with little arrows pointing in the direction. If you have the same number of arrows and they're pointed in the same direction, that means that the two lines are parallel. Okay, so the next one is skew. And skew is a non-coplanar set of lines, and they are not parallel and they do not intersect. So we're talking about three-dimensional now. They're not on the same plane, and they're not parallel and they do not exist. So let's say, for example, we have a cube. Okay, two skew lines could be this one right here that is going left and right on the top part of the cube, and then this one right here that is going kind of front to back on the bottom part of the cube. If these lines extended out forever, they would never intersect, and they are also not parallel. So you have one on a plane on top and another one on the bottom, and they do not intersect and they're not parallel. That is skew. This one you'll see very infrequently, but it's something good to know. And parallel planes is the last one, and they are planes that do not intersect. So instead of a straight line like we have up here, a plane is something like an entire face of the cube. So if, again, we're looking at some sort of three-dimensional object right here, and we can see all of the hidden faces. All the dotted lines are behind the cube. A set of parallel planes could be this top side right here and this bottom side right here. Those two planes are parallel to each other. They will not intersect if they extend out forever in all directions, both the top and the bottom. So those are the first three terms. And the last one is a transversal. Now, a transversal is a line that intersects with two or more coplanar lines. So let's first take a look at what two coplanar lines are. Let's say we have these two coplanar lines that are on the same plane, this piece of paper. A transversal is basically one that intersects these two. Okay? They don't have to be parallel, they don't have to be skew or perpendicular at all. As long as you have these two coplanar lines and this one that is a transversal that is cutting it or intersecting, then it is called a transversal. All right, here are the next four kind of theorems when looking at transversals and some types of angles that they form. All of these terms on the left are the labels of each of the angles, and all of the ones on the right are the descriptions on what is happening to these angles. So the first one is alternate interior angles. This means that the angles are not adjacent or not touching each other. They are interior, so on the inside of whatever transversal is cutting them, and they are on opposite sides of a transversal. So if we have two lines and a transversal, alternate interior means this one is an interior, and then the other side of the transversal is the alternate interior to that one. So they are falling on left and the right sides of the transversal, and they are both inside of the two coplanar lines. Same side interior angles are also interior, just like these up here, but this time they're on the same side of your line, of your transversal. So this one and this one are both same side interior angles inside of the lines. They're same side of the transversal, therefore they are the same side interior. Corresponding is, if you know what the word corresponding means, that means they are the same corresponding to some other side. So you could be sitting on corresponding sides of the classroom with another student. But when you're looking at two lines and a transversal, there are 4 angles formed at each of these intersections. So the corresponding angles could be one that is the top right of this set and the other one that is the top right of this set. So they have to be on the same side of the transversal, which is on the right-hand side, and they're on corresponding sides. So they're both above each of these lines. Just kind of look at this as a grid of 4 or however many angles are being intersected, and if they're in the same spot to one another, then they're corresponding. So you could have another pair that's bottom left of each of these, so this one and that one, they're both corresponding, and then you could have top left where they're both corresponding to each other. It's just, think about it as same side of the 4 angles. And then alternate exterior is exactly like it sounds based on alternate interior. They're not touching each other and they are on the outside of each of the lines. So if we have a transversal, alternate is opposite sides of the transversal and outside of these lines. So this one and that one are alternate exterior angles. Left side of the transversal, right side of the transversal, alternate, and exterior is outside of these lines. So let's take a look at one final example before we finish this video. We've got a diagram right here with 2 lines and a transversal, and I have labeled each of these angles as the numbers 1 through 8. And down here, we can find each of the types of descriptions for the pairs of the alternate interior, same side, etc. types of angles. So if we're looking at alternate interior angles, we're only looking at the ones that are inside the lines. So basically just 3, 4, 5, and 6. And then the alternate pairs are the ones that are on opposite sides of the transversal. So there are 2 pairs in this diagram of alternate interiors. 3 is alternate to 6. They're both on the inside. And then the other pair is 4 is alternate to 5, based on this diagram. 4 and 5 are alternate interior, 3 and 6 are alternate interior. Same side with same side interior angles. Looking at the insides, we get rid of those outsides, and it's 3, 4, 5, and 6 again. But if you do same side, that means it's 3, 5, and 4, 6, since they're on same side of the transversal. Corresponding angles means the exact same space in each of the sets of 4 angles. So we have 4 pairs this time. 1 and 5 are on the top left of each of the angles. 2 and 6 are on the top right of each of the angles. 3 and 7 are bottom left, and 4 and 8 are bottom right. So the first 2, alternate interior and same side interior, we only had 2 pairs. Corresponding, we have 4 pairs. Alternate exterior, we get rid of the inside angles. So we have 1, 2, 7, and 8 looking at just exterior. And alternate means opposite sides of each other of the transversal. So 1 and 8 are alternate exterior, and 2 and 7 are alternate exterior. Okay? Thank you.